Okay, turn to page 17, and we're going to start talking about the mole. Page 17, we're going to start talking about the mole. The word mole usually probably makes you either think of like a cute little furry creature, or maybe something like a large freckle that you have to keep an eye on in case you get cancer. But in chemistry, we have a third definition for the word mole, and that's what we're going to talk about today. Because sometimes we use specific words to represent a certain number of things, such as pair or dozen. The word pair should make you think of a number, probably the number 2. If Sam had 28 pairs of socks, how many total socks did he have? Well, 28 pairs, each pair had 2 socks, so 28 times 2 would be 56 socks total. Or how many items are in a dozen? The word dozen probably makes you think of 12. If Mr. Dado ate 6 donuts, how many dozen donuts did he eat? Well, he eats 6. Each dozen is 12. So 6 out of 12, that is a half dozen donuts. We need a bigger number when we count particles because they are very small and there are a lot of them. So instead of pair or dozen, we use the word mole. The mole is a unit we use in chemistry for very large quantities. So here is our new definition of the word mole. 1 mole of anything has 602 sextillion items. It's a very large number. That is our new definition of the word mole. This number is called Avogadro's number. It's named after a guy, Mr. Avogadro. And this number is usually written in scientific notation as 6.02 times 10 to the 23rd power. So 1 mole is 6.02 times 10 to the 23rd items. 1 mole of anything has 6.02 times 10 to the 23rd items. There are several types of items we could be talking about. Usually, for now, we're going to stick to atoms. Later in the year, we'll talk about other options too, but for now we're going to stick to atoms. Atoms are the smallest particle of an element, like silicon, carbon, magnesium, calcium, copper, zinc, sulfur. You know, an atom is just one particle. A particle could be any extremely small fragment or portion of matter. That could be an atom or a molecule, because both of those are small. So a particle could be an atom or a molecule, which is usually a compound. Again, for now, we're going to stick to talking about just atoms. We may sometimes call them particles, but we're not getting too fancy just yet. So let's look at a couple examples, like how many puppies are in 1 mole of puppies? Well, 1 mole of anything has 602 sextillion items, or 1 mole is 6.02 times 10 to the 23rd items. So 1 mole of puppies is 6.02 times 10 to the 23rd puppies. And how many atoms are in 2.5 moles of sodium atoms? Well, 1 mole is 6.02 times 10 to the 23rd. So to find 2.5 moles, why don't we just multiply those? Stick that in your calculator. When you type it in your calculator, make sure that you use the new E button we just talked about to do the scientific notation, 6.02 E23. So it should, in your calculator, it should look something like this. Although your calculator that is from my class set is probably nicer than this calculator I'm using at home. But it should pretty much look like that. And you press enter, and it should look like that. And if it doesn't, then you typed something wrong. So please, check yourself. Make sure you are typing it correctly. Don't just write down what I have on the screen. Check that you personally are typing it correctly. Make sure it looks exactly like this. And then once you're sure that you are typing it correctly, we can write our answer. The calculator says 1.505 E24, but that's not really how we're supposed to write final answers. First of all, we need to round to the hundredths place. So this 5 tells me to round up. Instead of 1.50, I should write 1.51. And then when I'm writing on paper, I shouldn't write E like that. I should write times 10, and the exponent is 24, like this. And then label it sodium atoms. Example 3, how many moles of kittens do you have if you have 6.02 times 10 to the 23rd kittens? Well, I know that this number is 1 mole. So if I have that many kittens, then I have 1 mole of kittens. That is a lot of kitties. A lot of kitties. Okay, turn the page. Or look at the next page, page 18. We can talk about moles not just as far as counting stuff, but also how much moles weigh. The mass in grams of 1 mole, meaning of 6.02 times 10 to the 23rd particles, of a substance is the molar mass. So like if we think about that mole of kitties we were just looking at on the previous page here. This is my attempt to draw a cat. Okay, here we go. There's a cat. All right. If I think about this mole of kitties and I've got 6.02 times 10 to the 23rd of them, that is a mountain of kitties. That's literally enough kittens to be about the size of, probably bigger than the moon. Okay, it's a lot of kitties. But if I took all 6.02 times 10 to the 23rd of them, I could put them on a scale and I could check what their mass was in grams. It would be a very large number of grams if I put them on a scale. But whatever that number was, that would be called the molar mass. That is the mass in grams of 1 mole. If you take 1 mole of something, stick it on a scale, and see what its mass is, that is called the molar mass. The unit for molar mass is grams per mole. It's written G/mole. Out loud, you don't say G/mole. If you say G/mole out loud, you sound like a moron. Say grams per mole. And then the average atomic mass on the periodic table, that is the molar mass in grams for every 1 mole. So your molar mass in grams is the mass of 1 mole, which will be 6.02 times 10 to the 23rd particles. And again, a particle could be an atom, a molecule, or pretty much any other item you could be counting. We're going to mostly stick to atoms in this unit. We'll do more. We'll expand to other types of particles in later units. Okay, what we're going to do for this unit is we're going to end up coloring a lot. So what I need everyone to do is get either your own or to share a green, a yellow, and a blue. Everybody needs a green, a yellow, and a blue. You can use highlighters, colored pencils, crayons, markers, I don't care. But you need a green, a yellow, and a blue. If you're using a marker, then try and pick one that's kind of light so that you can see what's under it when you color with it. Just my advice as a professional. You don't have to listen to me. Everyone needs a green, a yellow, and a blue. You can take a moment and pause the video if you need to make sure everyone has colors, at least to share. You don't need necessarily your own, but at least to share, you need a green, a yellow, and a blue. Okay, and at this point, if you have unpaused the video, hopefully everyone has colors at least to share for green, yellow, and blue. And here's what we're going to do. We're going to color code a bunch of stuff. All of the times that you see the word mole on this page, I want you to color the word mole green, always. So like I see the word mole here. I see it here, I see it here. Everywhere you see the word mole or the abbreviation MOL, I want you to color that green, the whole page down. The whole page. Moles are always going to be green, always. Okay? Wherever you see grams, grams are going to be yellow, or mass too. Mass is measured in grams. So mass or grams, that's going to be yellow. Think of golden grams, like the cereal. That's why I picked yellow for grams. So you could remember, like golden grams, the cereal. So everywhere you see a G for gram, color it yellow, the whole page down. I think I got them all. And then by now you've probably figured out the only color left or unit left would be blue. And blue is going to be particles, which, remember, particles can be just the word particles. It could also be, usually we'll be talking about atoms. So everywhere you see the word atoms or the word particles, color it blue. Molecules too, those are particles, atoms, whatever. Color it blue. And we're doing this for a reason. That reason may not become immediately clear, but I promise there's a reason. I'm not just a crazy person. I mean, I kind of am a crazy person, but that has nothing to do with this. Okay. When you go to solve mole problems, there are some steps you have to take, and there are some kind of shortcuts to help you take those steps, and those shortcuts are partially based on the color coding. So first, for your steps, we're going to write in this box. Okay. For your steps, you start with the given, which should be a number, a unit, and an element, over 1. Then you're going to figure out how many fractions you need and draw them. I'll talk about that some more in a minute. And then whatever they're asking for, the unknown, which you won't have a number for, but you'll have a unit and an element, goes on top of the last fraction. I know this sounds like gibberish, but don't worry. I will walk you through these steps so many times, and you're going to be like, wow, this is the same every time. And I'm going to be like, yes, that's why it's easy. Okay, so those are your basic steps. And then I guess from there, it's sort of just like recognizing some shortcuts to fill out your fractions. Oh my God, stop whining about fractions. I know you're doing it. There's at least one person in this class who every time I say the word fraction, you're freaking out. Quit whining. You'll be fine. Okay. And for these shortcuts, I want to notice some patterns up here. So, if you look at everywhere that we colored green up here, everywhere that we colored green up here, what do you notice pretty much all the greens have in common? It was the word mole, of course. How many moles? Pretty much everywhere we had green, it is 1 mole. So that's a little shortcut to keep in mind. If you have green, it's always 1 mole. Similarly, blue, you should see a little pattern. Next to blue, what number do we have, like, every time next to blue? Even all the way up here next to blue. When it's blue, you use 6.02 times 10 to the 23rd. And we're going to, in this unit, we're going to stick to atoms. Later on in the year, it can be molecules too, but we're going to stick to atoms here. Blue is always 6.02. It rhymes. Blue is always 6.02. When it's blue, use 6.02. It rhymes. That'll help you remember. Okay, and yellow, if we look everywhere we had grams up here, this one's slightly trickier. All these grams used 12.01, but the reason they used 12.01 is because carbon on the periodic table was 12.01, and this example was for carbon. So 12.01 grams of carbon is 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. That 12.01 is from the periodic table specifically. So yellow is not necessarily always 12.01, but it is always a number from the periodic table and it is a number of grams. And you pick based on what element the problem is about. Now that we have those out of the way, I also want to look in more detail at these fractions here. So there's this relationship that your number of grams from the periodic table for that element is equal to 1 mole of that element is equal to having 6.02 times 10 to the 23rd atoms of that element. And you can write that in ratios, just like in your math class. So like instead of saying, okay, for every 1 mole of carbon, I have 12.01 grams of carbon, I can write that as a fraction, 1 mole of carbon over 12.01 grams of carbon. That's a relationship where when these things are equal to each other, I can write them as a ratio, and this is secretly a 1-to-1 ratio because these things are the same as each other. Just like if I wrote 12 over 12, those are the same thing as each other, that is a 1-to-1 ratio. Or if I wrote 12 over a dozen, those are the same thing as each other, that's a 1-to-1 ratio. Same idea here. And you can flip it. For every 12.01 grams of carbon, you have 1 mole of carbon. You can put 12.01 grams of carbon on top, 1 mole of carbon on bottom. Same thing. Same idea with moles and atoms. For every 1 mole of carbon, you have 6.02 times 10 to the 23rd atoms You can put 1 mole over 6.02 times 10 to the 23rd. You can put 6.02 times 10 to the 23rd over 1 mole. These are still 1-to-1 ratios because these two things are equal to each other. We know that from up here. And having seen that, I want to see if you notice any patterns in the way these colors meet up. Like, for instance, the fractions with 2 colors, what color is always there? Sometimes it's yellow and something, sometimes it's blue and something, but if you have a 2-color fraction, one of those colors is always green. Another way to look at that, especially if you're colorblind, would be that if you have 2 units in the same fraction, one of them always has to be moles. If you have 2 units in the same fraction, one of them always has to be moles. Something else you may notice is that blue and yellow never go together. Never. None of these fractions have blue and yellow together. And again, if you're colorblind, you don't have to think of it in terms of the colors. You can be like, okay, atoms and grams never go together. And the last thing is we never have a fraction that is green over green. So, or you could say you're never going to have a fraction that's moles over moles. So these are some kind of shortcut rules to keep in mind. For here, I'm going to end this video for the day because I'm thinking you're probably just about out of time. Next class, you should end up doing the warm-up that's on page 16 to take a quiz over just scientific notation. That's what you're going to do next class. And then after that quiz, we'll talk more about moles in another video. So I'm going to stop this here for the day. I'm going to hand it over to Ms. Woodlock and have you do whatever she thinks you still need to do.